Hey, welcome back to Math 0955. Here is section 2.5 where we're translating English into algebra. So a very important subject in mathematics. A lot of math is aimed at removing all of the emotion and sort of speculation and intuition that we find in our everyday lives and trying to make it free of all of that. So, if you have an argument, you can just use math to deduce who's correct. More for us, more to the point, we would be using mathematics to solve engineering problems, maybe to figure out how thick to make the sides of a water tower so that the canister holding the water doesn't fall apart on us and that sort of thing. So you definitely don't want to be doing speculation when there's money on the line or if there's people's lives on the line. You want to remove all that human error, all that emotion and everything like that. So this is the beginning of that topic, truly the fundamental beginning, where we are just taking English sentences and turning them into equations or algebraic expressions. And for the most part, there's not too much to worry about. You can just translate these sentences word for word. But when you get to subtraction, there's a couple issues where you may have to reverse the order. And then another kind of bump in the road would be when you get to the bottom of table 2.1 there, where you have more than one operation. For example, the sum of twice a number and 7 versus twice the sum of a number and 7. You can see to the right, one has parentheses and one doesn't. So it's really the subtraction issue and then this issue that we need to watch out for in the beginning exercises. So let's dive into those exercises. And if I could find where my problems are, that would be just dandy. Okay, it apparently logged me out of them. So let me log back into them. Here we go, so 2.5. And just click on the first problem there and see what we're up against. Right, so you're literally converting word for word there. So it says on the left, a number increased by 30 is equal to 240. So that phrase, a number, that just means a variable. So for that, you would write x. Let me get my pen to work. Sorry about this. It's refusing. So there we go. Okay, sorry about that. Okay, so a number, we just say that's a variable. Increase means to add. And if you're not sure what one word means, then you just go back to the e-text and figure it out. So x plus 30 is equal to, that means equal sign, and then 240. And then, so once you write out the equation, they're going to want you to type in the equation first, maybe not necessarily answer it. But once you do type it in and check that part, they're going to want you to go ahead and solve the equation. So you're going to move 30 to the other side. And apparently we'll have 210 for our answer. Okay. So they're going to have a lot of those. Let's find one where we have maybe a little something a bit different. So here's a quotient. Quotient means there's going to be a division symbol. And for these, you kind of put the first number you see first, and then in the numerator, and then the second number you see in the denominator. So it says the quotient of a number and 19. So the number, again, represents a variable. And 19, then you put the 19 in the denominator. The word is equals, and then on the other side you say 4. Okay. All right, so they're giving you multiple choice this time, so x over 19 is 4. And then again, they want you to solve. So in this case, you'll multiply both sides by 19. On the left, you'll just have x. On the right, 76. The sum of 8 and twice a number is 34. Okay, so let's see. We have a sum, so we have the sum of two things. One of the numbers is 8, so I'll just put that first because it comes first in the sentence. And the other number is twice a number, so twice the variable. And then we see the word is again. And then on the other side, there's a 34. Okay. So write the equation. And then solve the equation. So we'll isolate the 2x using the addition property. A little bit of arithmetic. 8, 9, 10, 11, 12, 13, 14. So there's 6 of them. 26. Divide both sides by 2. And we get 13. So looks like 13. Yeah. Make sure you type it in correctly. Okay, so here's one of those subtracted problems. And usually for subtraction, if I see the word from, it's going to mean that you need to reverse the written order. So right now it's written 4 subtracted from the product of 5 and a number is 76. But when you see that word from, that means you're going to have to kind of reverse the order of the difference. So it's not 4 minus 5x. No, that's wrong. It's actually then you're taking 4 away from the product of 5 and a number. So you're going to write 5x minus 4 is 76. Okay, so it's just a matter of being careful. Of course, if you get it wrong on your first try, you get a second try. Nothing to be too worried about. And ultimately, this is just a way of introducing you to this idea that, hey, we can translate all of this communication that we have into mathematics and make it more rigorous, make it automatic. And you're removing all of the emotion that we humans have and all of the differing opinions we have. So 4 plus 6, 0, carry the 1, we get 80. And then we're going to divide 80 by 5. So, and if you write it out like that, you can write it like that. And then x will just be 16 here. So be careful when you have those subtracted issues. I don't know why it's not moving ahead now. Okay, so let's move on. So this is one of those ones where you have a multiple operations, right? So you have addition and then multiplication on top of it. So it says 3 times the sum of 5 and a number. So there's 2 possibilities. I'll write them over here to the right. 3 times the sum of 5 and a number. I mean, is there really even 2 possibilities? It's 3 times a sum. So you think of it as 3 and then parentheses, and inside there you're putting a sum of something, right? So in this case, it's 5 and a number. So it's 5 and a number, and then that equals 51. So the issue is sometimes you need the parentheses, sometimes you don't. In this case, it's 3 times the sum, and so you need the parentheses. And again, you could go back to the chart, the table, and kind of use that to figure out what's going on if you're just kind of throwing stuff at a wall. And it is a subtle kind of arbitrary almost feeling when you're doing some of these problems at first, but trust me, after a while it becomes very clear which way you're going. So I wouldn't give you one like this particular problem on the test, but those difference problems, yeah, those are fair game. I kind of expect you to know how to handle those. This one, maybe not so much. All right, so 11 minus 5, 6. 4 minus 1 is 3. And then we want to divide both sides by 3. So we get x equals 12. 9 times a number is, so let's skip this one. Let's try this one. Okay, so this is number 10. 3 more than 5 times a number is that number increased by 35. So again, whenever you see the word number, a number, the number, that's when you're putting in your variable. Let's translate it in order. So 3 more than means to add. 5 times a number is that number increased by 35. Okay, so again, just in order, literally whatever it says, that's kind of what I'm writing down. And then they're going to want you to solve it. So you get some more practice solving equations. All right, so here this one was a little more complicated, right? So number 11, the quotient of 5 times the number and 6. So that word and is kind of where you're going to put the fraction bar. Okay, so it's a quotient, so you need a fraction bar. The quotient of 5 times the number and 6, and then you increase that by 4. Okay, and then the result is 44. Then they want you to solve it. So in this case, let's clear out the fractions. So this is the type of operation we're going to want to be able to do for the future problems that will be coming up later in our lives. So it's 6 times 5x all over 6 when we distribute. And then plus 6 times 4. Let's just write that, 24. And then on the right-hand side, we have a little arithmetic. So before, and then a 2. And then 26 to 264, and then 6 times 5 over 6. 6 is cancel here, and then you just get 5x over 1, which is 5x. And then we have kind of the traditional linear equation. We're going to move the 24 over. And then we're going to divide both sides by 5. So you get x equals 42. Row, I must have mismultiplied or something. Something idiotic, no doubt. That's what I get for doing stuff in my head, I guess. All right, so 5x, 44. Multiply by 6. Did I screw up my multiplication? 4. Okay, the 2, that would be 26. 6 times 4 is 24. I'm doubting whether 6 times 4 is 24. So 5 is minus 24, 0. 4, 2. I have no idea what I did wrong. Let me pause the video and I'll figure it out. That I see it. Sorry about that. It's the last step. My division was incorrect. That's what I get for doing stuff in my head. So 5 goes on 24 4 times, you get 20. So bring down the 4, 0, and then that would be 48. So just x is 48. Oh well. Probably why I'm not an engineer. Being an engineer sounds so stressful to me, but if you're that kind of, you have to get everything correct and you're getting everything perfect and not making any mistakes, that's a good way to go. Because everything an engineer seems to do is just so important, right? You're making sure buildings stand correctly. You're making sure bridges hold all the cars. I mean, if anything goes wrong, oh my gosh, it's just a nightmare. So, I mean, I can't imagine being an engineer. It must be extremely hard. But if you like a challenge, and you really feel like you're up to it. Anyways, use 5-step strategies to solve the problem. So at this point in the book, what they do is kind of introduce a strategy where you're first defining one variable, so define x, and then secondly, you're defining everything else in terms of x. And then thirdly, you're creating an equation and solving it. Right, so you'll create equation and solve. And of course, then make sure your answer makes sense. Usually you have to do some back subbing. Let's try number 12. I don't know if I did it in class, but we'll do it again. And so the deal is you're looking at these sentences, and again, you're going to kind of turn them into math, right? So on average, I'm just kind of skipping through the beginning. They do some extra, I don't know what they're talking about, but on average, a person devotes 36 years to sleeping and watching TV. The number of years sleeping will exceed the number of years watching TV by 20. Okay, so that sentence right there connects the two unknowns. So I'm going to automatically just define one of those two things to be x. So I'll say x is the number of years watching TV. And then I'm going to define the other unknown in terms of x. So the other unknown would be the number of years sleeping. And that sentence connects the two, right? It says the number of years sleeping exceeds the number of years watching TV by 20. So if you know the number of years watching TV, to get the number of years sleeping, you just add 20 to it. So it's just going to be x plus 20. Then I want to build an equation. And actually the first sentence is what tells us the equation, right? It says, on average, a person devotes 36 years to sleeping and watching TV. So that means if you add the number of years watching TV, which is x, to the number of years sleeping, which is x plus 20, that sum will equal 36. And that becomes your equation, and you can solve that then. So you'll have 2x plus 20 equals 36. And then we can move the 20 over. And then we could divide both sides by 2. Okay. So 8 is the number of years watching TV. But we still want to find the number of years sleeping. So how do we do that? Well, we do what's called back substitution. We go back to that equation that tells us the other unknown. It's x plus 20. So putting 8 into that equation, or that expression rather, we'll have 8 plus 20 equals 28, and that'll be the number of years sleeping. So about half your life, you're basically sleeping, and that makes sense, right? You kind of, if it was 100 years sleeping, then you would say, well, I made a mistake, right? So it should make some amount of sense. And honestly, I think I spend way more time watching TV than normal people. Not that I'm not normal, but compared to people that compared to the average person out there, I think I spend probably a lot more time watching TV, which is not a good thing. I don't recommend it. Anyways, problem 13 is another one of these where you want to define, there's two unknowns, define one as x and then define the other as in terms of x. And this number 14 is a problem concerning consecutive integers, right? So 14, we're looking at a book, and it's saying that the page numbers are two consecutive integers whose sum is 321. So we'll say that this first page is X, right? And then we'll say maybe the second page over there, what's that got to be? So for instance, if the first page was 5, page 5, the second page would have to be page 5 plus 1, which is 6. So if you have the page, if you're just going to call the page X, then the right-hand page, to get its value, you just add 1 to it. So X is going to be your first page, and then X plus 1 is going to be the next page. Okay? And that's all they mean by saying that phrase, that the left and right page numbers are 2 consecutive integers. Okay? That just means one comes after the other, right? They're 1 apart. Then in that same sentence, it says that the sum is 321. The sum of those 2 page numbers is 321. So that gives you your equation. The sum of the first page and the second page, x plus 1, is going to be equal to 321. Okay, so adding x's together, you get 2x. 9 plus 1 is 321. Subtract the 1 over. And then finally divides both sides by 2. And it looks like the first page is page 160. And then, of course, to get to the next page, it's just 161. You just add 1 to it. So again, you're kind of back subbing into the equation. How did I get 161? Well, I just took 160 and plugged it in for x into the second equation. And so it's, I wrote x plus 1, but it's really 160 plus 1 down here. And then that's equal to 161, and that's the second page. Okay. So I'll go ahead and put it in just to make sure. Okay, great. The problem 15, then we kind of take it up a notch. This time, this says the number of home runs by player A and player B for a season are consecutive odd integers whose sum is 68. So in this case, when you say they're odd integers, you're thinking of numbers like 3, 5, 7, 9, 11. So if one number for the home runs is like, I don't know how many home runs people usually get, maybe 18. The next one, because they're consecutive odd integers, the next guys, and these have to be odd, sorry, 18 is even. So let's say 17, right? So player A is getting 17 home runs, and player B is going to be just 19. So if one person is getting X home runs, the next person is getting X plus 2 home runs. So it's a lot like the previous problem, except instead of going consecutive integers, you're going consecutive odd integers, so you have to add 2 instead of just 1. All right. Okay, so let's try number 15. And, the number of home runs by player A and player B are consecutive odd integers. So I'll say X is the number of home runs by player A. And we'll say X plus 2 is the number of home runs by player B. And then in the same sentence, it's giving you the equation. It's saying the sum is 68. The total sum of the home runs by player A, and then plus player B, that's going to be 68. So you're going to have 2x plus 2 is 68. Then you're going to subtract the 2 over. And then you're going to divide both sides by 2. And so player A has 33 home runs. And again, you're doing a back substitution to get player B's home runs, right? So you're just plugging in your value for X into that next equation. So it's going to be 33 plus 2, which is 35 home runs for player B. That's a lot of home runs. Okay. Okay, so player A is getting 33. Player B, 35. Okay, great. These problems are more in line with what you would see as they're more realistic. Okay, so problem 16 says a rental car agency charges $200 down plus 25 cents per mile to rent a car. Okay. How many miles can you travel in 1 week for $420? So that last sentence kind of tells you your unknown. X is the number of miles you can travel. Okay. And it says there's like a $200 charge automatically, and then plus there's 25 cents per mile. So 0.25 times every mile charge, right? And then plus that $200 down. And you want to know how many miles you can drive for 420. So in other words, the 25 cents per mile plus that $200 you put down, you want that to equal 420. Right? Okay, so believe it or not, that's the equation, and then you just solve that equation for x. Divide both sides by this. Oops, not the x part, just the 25. And I believe x would be 880. Just a quarter is 1/4, so you multiply by the reciprocal. 4 times 220 is 880. 880 miles. So the kind of the form for these problems, it's the charge per mile so cash per mile times x plus kind of your down payment is equal to the total charge. Okay, so if you want to, you kind of think of these problems in terms of a formula, that formula I just presented there. If I remember this question 17 correctly, there's a lot of kind of nonsense information. It seems like you don't need it all. You're just kind of you're just going to look at row 1 because we don't really necessarily need row 2 to answer the question. So every once in a while, they're going to give you all kinds of extra information. You kind of see that if you ever watch like lawyer shows, one of the lawyer will try to bury the truth and all kinds of extra info that you don't really need. I don't know, but let's read it. So in 2017, the most popular cars were car A and car B. Shown below are the 2017 and 2018 average gas costs for each car and the annual increase in these costs. In 2017, the annual gas cost for car A was $1,574, increasing by $315 per year. If this trend continues, how many years after 2017 will the gas end up costing $3,779? And in which year will this occur? Okay, so the question that you have to answer: how many years after 2017 will the annual gas for costs for car A be $3,779? So notice they don't ask anything about car B. I mean, an extra thing that you should be kind of learning how to do here in college is figuring out what's important and what's not. Like I said, sometimes people try to confuse you with all kinds of extra business, and it's just not important. You just got to figure out, what do I have to study and kind of what isn't important to study. I mean, that's kind of 90% what you do as a student, right? But anyways, here that car B, you just don't even need it, so that's okay. That means you have kind of less stuff to worry about. You want to know how many years after 2017 will they get? So that's your variable right there. So X is the number of years after 2017. And I believe the formula is going to kind of work like the formula above it. So you have this kind of initial amount where you're starting at, in this case, $1,574 in 2017. And then it's saying it's going up per year by $315. Right? And then at the end of the day, we want to know when is it going to equal $3,779, right? So it's almost the same idea as before. You kind of have this rate, a charge per mile. Here it is kind of an increase per year, X, and then plus your kind of starting place, your down payment, and the other problem, and then kind of your ending place. And the previous problem, the total charge. In this problem, the cost in a particular year that we care about. Okay. So anyways, once you get in this form, we should be able to just solve it. Okay. And I'm gonna need my calculator this time so I don't screw it up. I already screwed it up. So 7 years after 2017 is going to be kind of our answer. I hope. Yeah. Oh, and then they want to know the actual year. So you just add 7 to the 2017. It sounds like 2024. Okay. Okay, so then they're going to start beating you up with geometry problems. 2.6 is all geometry, if you've not looked at it already. There's going to be a ton of formulas we're going to throw in your lap. I expect you to know some of them. Some of them I'm not too worried about, but the basic ones, I don't want you to embarrass yourself out there in public. If somebody asks you the area of a circle, you should know that, okay? Some people use it as an impromptu IQ test. Like, this guy doesn't know the area of a circle, or must be, no. Okay, nobody really needs to know the area of a circle unless you're a geometry teacher or an engineer or something. But you should know, just so you can deal with these kind of people. So yeah. And if you're going to continue in math, it is important. It's a big, I shouldn't have said that. Okay, so it's important that you should know the area of a circle. Okay? That seems like a fundamental thing that I just think everybody should know. And if you look around in, not to go off on a tangent, but if you look around on the planet, you know, there's so many things that are circles, right? If you look into your friend's eyes, you see circles. If you look up in the sky and you see the sun, it's a circle. If you look up in the sky at night and you see the moon, it's a circle. If you look at cars, their wheels are circles. You know, it's all over the place. So I don't know. Just trying to get people to do stuff, I guess. All right, so here the rectangular field is 4 times as long as it is wide. If the perimeter is 480 yards, what are the dimensions? Okay, so very basically, you could draw a picture of a rectangle. So it's not quite a square, right? The sides are parallel, but all the sides don't have to be the same length. Okay. The perimeter of a rectangle is going to be the sum of 2 times its length plus 2 times its width. Okay. In this problem, one unknown is, let's just say, the width here. So we'll say the width is the unknown, and in the problem it gives you a way of defining the other length in terms of the widths, right? So it says a rectangle field is 4 times as long as it is wide. Okay, so if the width is x, the length must be 4 times x, in other words, 4x. Okay, so we can put that in there. All right, now we're going to take that information and put it into the perimeter formula because we know the p-value here is actually 480. That's also given in the story problem here, okay, 480 yards. So what I'm going to do then is use this equation and substitute in all these unknowns. So I'll have the perimeter, which is 480. Okay, so I'm using this equation. Equals 2 times the length. Okay, so the length, just one of, there's two lengths here, right? There's that 4x and this 4x. We just want to put 4x here for length. And then plus the width, so 2 times the width, which is x. And then that's your equation. And we can go ahead and solve that. So 480 equals 2 times 4, I can multiply that, that is 8. Simplify the right-hand side by combining like terms, and then divide both sides by 2. And it looks like the width x is 48. When you do these problems, you have to include units. So in this case, from the problem, it tells you we're working with yards, so it must be 48 yards for the width. And then the length is just 4 times that, so you're back subbing, right? You're using this 4x formula and then plugging x in for the 48 and for x. So you'd have 4 times 48. So 4 times 8 is 32. So 2 carry the 3, and then 16 plus 3 is 192. That would be in yards as well. Okie dokie. This is about the same type of problem. Let's get another one. This is the bookcase problem. I usually will include this on tests. Let's just go through it really quickly. You have this big bookcase, 3 shelves, I guess, and then a divider in between. It's saying that the length is 3 times the height. Okay, so we'll define the height just to be x, and then we can say the length is 3 times that value, in other words, 3x. Okay. The lumber available for the entire unit is 45 feet, okay, and then they want you to define the height and the width. Okay, so how many 3x pieces of lumber are there? Well, there's 1 of those, 2, and then 3, and then 4. 4 of the 3x's. So you write 4 times the 3x's. And then you have to add in the number of x's, right? The vertical pieces of wood there. So there's 1 of those, 2 of those, 3 of those. So you go plus 3, and each one has the length of x. Okay, the sum of all that, all those lengths, has to be 45 feet. That's given in the story problem. Okay? 45 feet of lumber is available. Then you're just going to solve this thing, right? So first simplify. 4 times 3 is 12. 12 plus 3 is 15. And then you're going to divide by 15. Okay, I think that's 3. So the height, x, is 3, and then you back sub the x into that 3x for the length, and that's just going to be 3 times the 3, which is 9. So it's going to be 3 feet high and then 9 feet in the other direction, and 9 feet in length. Okay, these next set of problems are kind of percentage problems again. And the idea is similar to figuring out your total cost when you go and you buy something with tax. So there's going to be the actual charge or price, and then there's going to be a tax. And to figure out the tax, it's going to be a percent times the price. Okay, so you have the price, and then there's a percent times the price, and then that equals kind of your total price, right? The total charge. So these problems are kind of a variation on that idea. So problem 21, I mean, it's not exactly the same, but it's that form, right? It's that shape. So you classify all things that are around, you know, bowling balls, some watermelon are kind of roundish now. But anyways, after a 60% reduction, you purchase a new soft drink machine on sale for $288. What was the original price? So the original price is unknown. I'll put that in for this thing right here. And then there's a reduction. Okay, so instead of adding on like a tax, you're reducing the original price. And it's going to be some percent. So in this case, it was a 60% reduction of, means multiply, the original price. And then the new price, the price that you pay is $288, right? So it's that form. I had to kind of cheat a little bit with the plus, and this is a minus because it's a reduction. But hopefully you appreciate, oh yeah, that's kind of the same. You know, an apple and orange are kind of the same shape. Not quite, but they kind of are. So anyways, what are we doing here? X is the same as 1x, right? So it's just 1 minus 0.6 is 0.4x's. That'll equal 288, and then you're going to divide by 0.4 on both sides. And I go to the Calcutron. $720. Wow, really? So the original price of the soft drink machine, that's a heck of a discount. Yeah, 60% reduction, that makes sense. Okay, great. Same type of problem here in 22. The cost of living went up 8%, so this time you're adding it in. Fortunately, oh, wait a second, maybe not. Fortunately, Alice got an 8% raise in her salary from last year. This year she's earning 46 grand. How much did she? So again, it's kind of like this. There's this original salary, and then it said she got a raise. So you're going to add in a percent of the original salary, right? Converting 8%. So remember, when you convert a percent over to a decimal, you're moving 2 places to the left, right? So this would be 0.08. Okay, so it's the original salary plus an extra percent of that salary, so 0.08 of means multiply x, and then that equals the new salary, which is now 46,230 bones, right? Okay, so adding together then again, x is the same as 1x, so I get 1 plus 0.08 is 1.08x. And that equals 46230. Divide both sides. 6, 2, 3, divided by 1.08. And that's going to give me a weird number. They want it rounded to the nearest hundredth. So tens, hundredths, that's the 2 decimals. So the original salary was $42,805.56. Type that in and see if it's right. 42805.56. Same jazz here. You know, you have some original price for the end plus 0.05% of the original price would equal the amount you're having to pay. Let's leave that one for you. This is another one of those. We'll do this one. Auto repair shop charge $390. This is kind of like a price where you have a cost, a fixed cost, and then you're adding in some variable cost because of the cost per hour. So going back to this problem, it's kind of like if I wanted to reimagine it, there's a fixed cost, and then there's this variable cost over here. So it's always like that. The variable cost plus the fixed cost. Okay, so let me write that again. It's generally for these problems, you're going to have some variable cost. So you'll see that as a rate, like dollars per second or dollars per minute, dollars per hour, I think in this case, $62 per hour. Let me read the question. An automobile repair shop charged the customer $390, listing $80 for parts, that's the fixed cost, and then the remainder for labor, which is variable. If the cost of labor is 62 bones per hour, how many hours of labor did it take to repair the car? Right, so there's this variable cost, which is dependent on the number of hours for labor. And then there's this fixed cost, which is going to be, the variable cost, back to the variable cost, that's $62 per hour. The fixed cost is going to be the charge of the parts. So usually when you go to see your mechanic, he'll come out and tell you, well, it costs this much for parts, and I don't quite know how long it's going to take. It may take 3 hours, 3.5 hours, depending on what we find. And so that variable is variable, but the parts, here, look, you definitely have to pay this for parts. Anyways, the total charge was $390. So over here you have the total cost. And then you should be able to solve for X, the number of hours of labor, if you didn't know that, right? So 62X plus this fixed cost for parts, they said it was $80 in the story problem. And then that equals the $390, which was the price out of your pocket, right? Usually it's about $1,000 whenever I go. Don't go to the dealer. Well, I shouldn't say that, but it seems like every time I go to the dealer, it costs me $1,000. I don't know why. So after a while, I'm just like, I'm not going to the dealer. Anyways, that's my own opinion about dealers. I don't really know. It's not like I'm taking in my car every freaking 5 seconds. Divide both sides by 62. I've got to watch my opinions, These are my opinions, not the school's opinions. Divide both sides by 62. So it must have been about 5 hours work. That's a long time. A lot longer than an oil change, right? So it took 5 hours. Make sure you put some units in there if you're on a test. Write it out in a sentence. Yay. And this is just some clever kind of puzzle question. I don't think it's all that clever, but you're going to have to play around with. I'll leave that one for you, so you play around with it and see if you can figure it out. You may not have to do any algebra. You may be able to just kind of guess, but. Okay, so as usual, I hope I helped out a little bit today. Keep chugging away at that homework. Get that homework out of the way and done so you can focus on other things in your life. I recommend in class always kind of do a little every day. Okay, don't wait until the last second. When I mean a little, I mean like hour, 2 hours a day. That's usually what it takes. And okay, so I'll see you next time.